Hey, Cole, you're on mute, I think.
There we go. Can you see my slides? Does it look all right?
Perfect.
All right. Hey, well, thanks for having us. I think Evan's talk is a really good segue to what we're doing. Kind of shows how we can use SPIFFE Federation to protect and secure the supply chain between multiple parties. So start by doing some introduction. My name is Cole Kennedy. I'm a solutions architect and director of defense initiatives at Boxboat. I contribute to CNCF six security supply chain working group a bit. We're working on a white paper over there that kind of talks about what the best practices are, what some gaps are in the area. And then most of my work is in defense. Also do some work in banking, and then we have a really cool somewhere between proof of concept MVP that we're doing on the electrical grid with using SPIFFE SPIRE for identity and orchestration. So, and then also with me, I have Mikhail Swift, and I'll let him introduce himself.
Hi, I'm a DevOps engineer at Boxboat. I'm also contributing to the CNCF6 Security Supply Chain Working Group. In the last few years of my career have been focused on enabling modern software development within the defense industry, but I have years of general software development experience as well.
And then Boxboat, we are a services provider. So if you're looking for any help with any of this stuff, feel free to reach out. But I'll leave the sales pitch at that. So the problem we have is that our customers really need a way to assess the risk level of software that's running in our systems, right? And then most organizations don't even sign that artifact or the metadata is because securing and distributing those keys is really difficult. Well, we're at this SPIFFE Spire Community Day, so we all know we have solutions for those problems. But it comes back to you can deliver that software faster, but if you don't have that identity and you don't really know what goes into that software, right, you can really just be delivering those vulnerabilities faster. So I really like to decompose zero trust architecture into these three concepts: identity, control, and policy. Policy, that's our constraints of our system that our users, our administrators can work within these left and right limits. Control, right, that's going to be the things that take your identity and your policy and put those together and make a decision on what's going to happen. So in a traditional CI/CD pipeline, right, the execution systems at the right, they really don't have any knowledge of what goes into a build process, and that means we are placing all of our trust in that actual build process, not the actual data that's produced during that build process, right? So our trust chain gets broken at the deploy or the distribute stage, depending on how your organization does signing and distribution. Right. So what we really want to move to, and this is a lot of work's been done over the past year or so on this. The NTIA has done a lot of work. Alan Friedman is probably the guy to look on that, and then a lot of people have been working on that, kind of looking at what he's doing, uh, and kind of develop this model. So MITRE put out this paper, Deliver Uncompromised, Securing Critical Supply Chains. Right. And that the thing is that every stage of a build process outputs metadata, and that metadata should be signed and then distributed along with that artifact. And that allows us to inspect that metadata and assess for ourselves what the risk of that artifact is, rather than relying on a third party to tell us what that risk level is, which obviously doesn't work that way. So now we're actually placing our trust in PKI and not process. So with this, and when we include SPIFFE Spire, right, we can do things like tie build process to specific containers with their container hash, to specific machines, maybe with, we built a TPM plugin for some work, or modified a TPM plugin for some of the work we did. You can tie build process to specific machines with stuff like that, right? So those are the type of guarantees that we want in order to trust our artifacts. So we looked at this tool probably starting about a year and a half ago in-toto. In-toto is a great tool. It wraps any CI process and records hashes, inputs, and outputs and byproducts of different build processes. So let's say you have a go build command, right? So then you'd wrap that in-toto go build and then also specify what files go into that build process that you want to record those hashes of, and then what files come out of it that you also want to record the hashes of. So you record all those hashes, you sign it. There's a lot of information on in-toto, so we're not going to dive too deep into that here. But the thing is, you're signing that metadata to provide that cryptographic assurance. And it does this all out of band. So what's really great about in-toto is that you are verifying by policy. So they have a file called a layout, and the layout file defines all the steps that need to happen to your build process. So in that layout, you can define that, you know, a certain process in the build needs to be signed by a specific SPIFFE identity. And so the project owner defines that. And then along the process, you have all these functionaries, and these functionaries actuate that process, right? So the functionaries will actually, you know, they're responsible for building it and then signing the metadata. And then the project owner, via that layout file, right, they sign that layout. And during that layout process, when that's verified, we want to make sure that those identities in that layout match with the identities in the metadata that was outputted. So this requires a private key for each of these functionaries. And that's been a really difficult problem in large organizations, how we distribute those private keys for these build processes. So SPIFFE SPIRE, right, this really helps out with a lot, right? Because we can tie these build processes to specific identities. So it allows us to build, it's allowed us to build these build attestation pipelines that kind of look like this. So we talked a little bit about the federation, or Evan talked a little bit about federation in the last talk. And this is how we can use federation actually to exchange trust between attestation domains, trust domains, and verification trust domains, right? So your verification trust domain may be your point of distribution, or it may be your point that the process is actually executed. So at that point, that is where we want to verify all that signed metadata. And then at the attestation domains, that's where we're actually going to sign that metadata. So we register these workloads with our workload identity and our machine identity in the SPIRE registration. And when that process happens, right, we see that, hey, this is that specific process. So SPIRE issues that process a signing key, a short-lived signing key that then signs that metadata that's produced. And then that signing key goes away, never to be seen again. And that produces that along each step of the process, we produce that body of evidence that then can be verified cryptographically at the verification domain. So with that, I'm going to hand it over to Mikhail Swift, and he's going to go over a actual proof of concept that we did using some GitLab pipelines.
All right, I'll be real quick with this. But so we have this sample Go project that we built, and we have a pretty simple pipeline for it. A clone, a build of the binary, a build of a Docker image, scanning for vulnerabilities, and then verifying everything that works or that was done correctly. So this is the layout that Cole was talking about, and this defines our build policy. So in each layout is comprised of multiple steps. In this case, we have a clone step, and we can say that the command that we expect to be run is this. So when we verify, we can detect any differences that happen in the command. Materials are the inputs, so anything that are going to be used during this to generate products, and products are the output. So we're creating the world essentially with clone. We don't want any inputs. And then for build, we're going to make sure that all of our materials that we use match the products from clone, so we don't have any unexpected source files or any changes, and disallow anything else, so no extra files should be provided. And we're going to create a single file with of a binary. So what we did to really kind of enhance in-toto for our purposes here to integrate it with SPIRE is we have it tied so we can verify trust back to our root CA. And then in our SPIRE, we set this as an upstream. And then in each step, we define who's a functionary based on some constraints on the X509 certificate, in this case, the SFID. and we're grabbing the SPIFFE ID as the URI. It's saying it must have this ID to qualify as a functionary and be able to run this step. You can see here that I made a merge request that changes the files outside of an in-toto run. So I'm modifying the source before the build process runs. And you can see here my verify is going to fail due to unexpected artifacts. Our main.go file no longer matches the clone product. So we can no longer use it and verification fails. So that's kind of how we're using SPIRE in hand with in-toto to enhance our build supply chain security.
So what really makes this great is that when we combine this with what SPIFFE SPIRE does for key exchange, we can build really complex build systems with multiple parties and multiple verification domains, and that all can be cryptographically verified and automated. This work was done. We needed to fork actually the in-toto Golang. So a lot of this work is not upstream yet. Mikhail and I are working on creating a proposal to upstream the CA certificate changes that we had to make. But otherwise, this works okay. So hey, go ahead and pull this down, play with it if you want, and ask us any questions. We're on CNCF Slack and also on SPIRE Slack as well.
Thank you so much, guys. Any questions for? Yep, echoing Evan, super cool work. Thank you for sharing. Any other questions for Cole, Mikhail? And while we are, sorry, go ahead.
Question. The verifier part, is the verifier code part of in-toto project too, or?
Yeah. If you go to the project, you'll see it's just another Cobra command in there, in-toto verify. There's some work that has been done, created a mission controller with that. I think we could also probably create a SPIRE plugin using that, which would be super cool.
Oh, cool.
I kind of skipped over in the demo, but you can define commands that run as part of the verify step. So it can do things like untar a package tar that you may have packaged prior and verify that everything within the tar is expected products.
Oh, cool. Did you have to, was it very difficult? I think like one of the difficulties I see in using X509 stuff for these purposes is the expiry. And I think one common way to work around this expiry issue is to ensure that the signature was created during the validity period of the original document. And I'm wondering if that was a really difficult thing to do.
Yeah, that's something that we are actively working on refining, but we are using trusted timestamping or looking at using trusted timestamping to ensure that everything was valid or created during the signature or the certificate's validity period for sure. Especially with short-lived certs.
Yeah, just because their certificate expires, does that mean we lose all trust in it immediately? Maybe not, right? I think those are some things that we need to talk about as a community and how we trust certificates, especially as we have the ability to use these short-lived certificates. And if we're using it for signing, right, that's different than using it for an active workload. So definitely some more discussion to be had around that area.
Totally. Yeah, I mean, it makes sense to me that, maybe it's expired now, but if it was valid at the time of signing, then that seems pretty reasonable.
And I think Mikhail and I, we had the thought of if the SPIRE agent actually had some sort of a timestamp API where it could you could send hashes to it and then it would return a signed timestamp, and then we wouldn't even need to expose private key material to the workloads to sign stuff. I think there's a lot of use cases we could use, including like CI/CD stuff for that.
Yeah, well, I'd love to continue the conversation there at some point.
Yeah, for sure.
Thank you for presenting.
Thank you.